very kind of like broadly about where I see the arc of the course going, and then how that fits into the midterm, how the midterm will be assessed, what is going to focus on, is just very responsible. And let me lead off by saying I know that in the homeworks I've pushed you very hard, and that's because I want you to learn, right? Like the whole point is that we don't just want the education that we get from content to be all about simulating. We want there to be actual human capital that you require value in the care process. The way the course has been structured is like most of the homework's on the first half of the course, and so the goal of that is really to tool you up. So that when we get to the second half of the course and start to read papers, that you feel very confident that you'll have the ground and you'll be able to do that. The way that the course has been structured too is that you're in groups. And so the amount of bandwidth that you have working as a team of 2 or 3 should be larger than you have as working in. It's just one person too. Right? So that's why I'm able to push you a lot harder in the midterms. You should not expect that the midterm is going to be as challenging as the homeworks, right? That would not be reasonable. So everybody can just breathe a sigh of relief about that. In terms of my philosophy too, like if all of you work really diligently, like I would be super happy to give everybody a A because you would have earned an A. The grading scale is going to be completely predetermined, so you know what it is from the syllabus. 85 and above is an A. I think it goes in 15-point increments, right? So I really believe that I want to give you the tools to succeed on the exam. And if you study hard, you work hard, you'll get an A in this course. That's just the way it is. You're not competing with your neighbors. You're not competing with the person that's not your neighbor. You're competing with yourself. Okay? Okay. So once we're done with this first half of the course, what we're going to do in the second half of the course is we're going to be reading a lot more papers. We're going to be talking a lot more about specific policies. So what we've done so far is we've developed a lot of the technical machinery. There are a couple other machinery things that we will do. So you guys have done this data tutorial, and for some of you that may have been a first time, for others of you that may have been a refresher. But what we'll do is we'll have a specific exercise around data that will allow you to work on a problem set where we have a question regarding the effect of educational wages, and then you're going to step through that exercise and be able to implement some of the tools that we have done. So in the previous lectures, what I focused on is trying to understand how do we estimate the returns to school. So this is when we went through how do we compute the sum of the square residuals, how do we think about the line of best fit for the data, what does that mean? Because I don't want you to just run a data command and just be like, oh, and this is the answer that we got out. But I really want you to think deeply about how are we generating this answer? What's going into this? What are the biases that it's subject to? And after that, we talked about, in the previous lecture, we looked at instrumental variables and trying to understand when there's something that is unobserved, that's correlated with what's observed, how does that bias work? At the beginning of the course, we talked a lot about utility bias. So we see that folks who go to school, they earn on average higher grades than folks who don't go to school. However, those folks who go to school are also different on unobservable characteristics. And so some of the returns to schooling can be coming through this channel of like the other characteristics that we don't observe. That makes it easier for them to go to school, but that's also positively or negatively correlated with their wages condition on going to school, right? Okay, so let me talk more specifically about the midterm. So the way that it's going to be structured, and I've written about like 2/3 of it, and I have a clear sense of how it's going to be structured. So there will be a set of short answer questions that will either be true or false or multiple choice questions. And these are going to test like your general knowledge. So these are going to be like easy points that you should get, but they're going to require you just to think and to have like some kind of insight into what we've done before. It could be a definition for a term like exogenous versus endogenous, or what is a corner solution, or it could be what is the marginal utility of a particular utility function with respect to x or y or whatever it is, right? And so there'll be those sorts of questions that will be true or false. And like these should be relatively easy for you to go through. And then the 3 main topic areas that I'll cover, that we'll cover in the midterm. So we looked at signaling, which you did from the homework. So you're very likely to get a problem that will be very similar to that problem from the separating equilibrium. So be able to know how to do that. And as I continue, my basic philosophy with most courses is that there's probably about 15% of the material in a given course that's really important for you to know for practical purposes, and I try to make that 15% of the course 85% of what I teach. So like in theory, like everything that we learned was actually super relevant. So the signaling is going to be something that's going to be really important. In class, we also did an example of how do you compute the returns to education as well too. And so you should be comfortable with that. So if, for example, I gave you a set of data and I said, okay, compute what the slope and the intercept are for that, you should be able to do that. Bring a calculator. You will need it for those specific things. Does everybody here have a calculator, like just a basic scientific calculator? Yes. Does everybody know how to use a calculator? Okay, good. But then there'll also be a question on present value, looking at how do you evaluate the returns to going to school versus the returns to not going to school. There will be some variations on these questions relative to what you did in the homeworks and in the lectures. It won't be exactly the same thing. There will also be some interpretation questions as well too that I will ask. And so I'm trying to lay out for you in very broad terms kind of like what the main things are going to be that's on the test, so that you can come in and you feel like you're surprised. But then to also expect to think on the test. Right? It's not just going to be that you're completely spoiled for that. And so at a very high level, like so those are like the four main question types. So we have kind of like this grab bag of true false that can come from anything that we've covered, from like a definition to like a very simple calculation. Here's the present value, computing the returns to schooling from a given example, and then the third thing was the present value calculation. So those have been like the main things. If you're able to grasp those concepts, there's no reason why you should not be able to get a game on this midterm. Some of you asked, how should you study? So I believe in conceptual learning, and so like everything that you've seen in the notes should help you with the study. I would encourage you to come up with like variations of the homework problem. So if a homework problem had parameters, like put in actual numbers and like work through the calculations, things like that, to really kind of like write problems for yourself and then solve them, and then be confident in the answers that you've got as well too. If you can do that, you will do well. Let me stop there and ask, are there any questions about what will be covered on the midterm or the format or anything like that? Yes.
How much will we be tested on actually knowing, like with marginal utility, actually doing like partial derivative calculations?
That's going to be a part of it. So you should know how to do that, because we've calculated like a gazillion derivatives in this class. So you should totally be able to do that. So like go back to that. The first homework where we had those three questions, like you should be able to compute those marginal derivatives like relatively easily. That can easily be like a true false question, or that can be a multiple choice question, or even like a short answer question. So that was yes.
How difficult are like the derivatives going to be? Because I know like, will it just be like the push rule and like a couple other rules, or will it be like on one homework we have a really difficult derivative?
So it won't be as difficult as the derivative on the theoretical exercise. It won't be as, everyone's breathing a sigh of relief. It won't be as difficult as that, no. But it will certainly be at the level of the marginal utilities that you saw for the homework one. Like definitely, like anything of that level is going to be fair game. And the thing about it too is like, you know, with that theoretical exercise, you guys were like benching like 350 pounds. And so like if I give you 200 pounds to bench, you're like, I got this. Question.
We'll spend the whole class, TJ.
Yes. If you're super fast, you'll finish beforehand. But I'll set it so that you. And Shannon will help me on this. She'll help me to make sure that the test is not too short and it's not too long. But you should expect to spend the whole time. And the hope should be that it'll probably. So our class goes for an hour and 15 minutes. You should expect to spend at least like an hour and 5 minutes, and then maybe like 10 minutes to review answers, that would be my guess. But if you're super efficient, maybe you can finish in 15 minutes or 45 minutes. Questions? No? Are you guys just being shy, or are there genuine questions? Yes, I talked to Shannon about that, so we'll have them posted by maybe like Friday.
Probably Friday by 5.
And I encourage you to study for the. I encourage you to study among your groups for the problems, and like even what would be cool too is like if you like set problems within your groups and you like give each other problems to solve. Like you create a problem to solve it, and give it to your group, you can do that. Because I would really want you to generate your creative thoughts as you go about preparing for the homework. Other questions?
With the answer key, or is it just gonna be you, like, just the answer, or you're gonna show us how you got there?
I'll put the steps on there, like following along in the steps.
So Shannon will do that. With the homework, so we have clue books. Like, is it the student's responsibility to bring clue books for the? How does it work in your other courses?
Depends on the exam.
Okay.
I
Like
think you have to ask them to
Say
that again.
I think you might have to ask the department.
Okay.
Like some departments provide them and some don't.
Okay, so we'll figure that out, and I will provide I'll provide whatever test resources for that. Let's see. So bring calculators. There's no cheat sheets allowed. There's no cheating allowed also. This is like you've done homework in groups, but you do not do the test. Like cheating is really annoying because it's like if people cheat, then I have to report it, and then there's a whole process where like you go before the dean and all this stuff happens, and it's just not fun. And it's not worth it because like if you get found cheating, you get 0, and it goes on your transcript, and it's really not fun. Like I prefer if you don't cheat. It's easier for me. Like just don't cheat. This is like I can't remember the percentage of your grade, but it's not like a super big percentage of your grade too. So you don't want to like cheat before the term or after the term or ever. Like just don't cheat. Right? Can we all agree not to cheat? Yes. Who pledges not to cheat? Look around. Yeah, and I mean it. It may sound like I'm joking, but when I was at Harvard, there was an introductory computer science course, and like 100 people cheated on this exam. It was really bad, and the professor like reported it, and then it went to the president, and like it just made the New York Times, and it just was an embarrassment for the whole university, right? And so we don't want to embarrass the university. We want people thinking when they think about clubs to think about football, not about football. So Deshaun Watson will be very disappointed in you if you cheat. So think about that as you other questions? Goodness.
For
You guys?
the, I'm sorry.
Yeah.
For the true false short answer, is it going to be like if it's false, then you have to explain why? Like if it's true,
Yeah, I'm thinking about that. Like I'm leaning towards no. Like if I do require you to explain, I'll ask you to explain.
okay.
But like if I don't ask you to explain, it'll just be true false. And if there's no explanation required, then the points will be less.
So it's like,
So that will be explicit. But the point of those questions is really to allow me to test a broad variety of things reasonably quickly, and then also to give you some easy points. I'll try to structure the exam so that the easiest questions come first, because I feel like that helps to build your confidence. And feel like, yes, I have these first 10 points back. So don't screw this up.
So you mentioned no cheat sheet. Are you gonna give us like the Lagrangian method equation? Like do we, or however you say that, like do we need to know that on the test? Like, or if it's something like that, will you put that on there?
Yeah, good question. I'd like you to know stuff because it's I like you to know stuff because when you go out in the real world, like it's good to be able to go then to do stuff. Like you see when I go on the board too, like sometimes I don't have my notes because I want to do it in real time so that you can see what's happening. You should know that. So Lagrangian is just the utility function, plus lambda times whatever the budget is minus the expenditure. That's just it. And then you take derivatives with respect to x, with respect to y, and with respect to y, and you set everything equal to 0. So it's like 2 simple steps. So you should definitely know that, right? That's one thing that you should know. You should know for the present value calculations, like what's the expression relating like the nth sum. Remember that Sn sum that we did in class? And like even if you forget that, you can derive that, right? Because I showed you how to derive that in class, and you can literally do it in 3 lines, right? Yes? No? No?
So I think
I'm just thinking about what it's
what I'm
like.
more concerned with is that we're going to be tested on like our knowledge of calculus or econometrics more so than we are the actual material that we're trying to learn, even though it is related. So like for intermediate micro, we didn't do any calculus whatsoever. It was just, or if it was like, yeah, the utility function is 2x and marginal utility is 2.
Okay. What's your question? No, I'm being serious. No. You have a question. Please give your question. Oh, your concern.
Like we're being tested on like our math skills. Like me personally, I'm not that good at math. Like,
Yeah.
and I think that's what you're trying to get at. I don't know.
Like even though we understand utility and stuff like that, we might not be quite as well versed in that calculus to get to,
Yeah. So that's okay. So like, what happens as you go through your training? So like, I think all of you in here are for the most part juniors and seniors and master's students. And so the whole idea is that when you're taking your intro and intermediate classes, it's about giving you like a notion of like, well, what is economics about, and kind of like how do you understand what's happening on a qualitative level, but even on to some extent a quantitative level. The goal of this of your more advanced classes, juniors and seniors, is really to develop the technical machinery to be able to answer questions that you may have like in a real world setting. Like if you were a consultant for McKinsey or for me, and they said, okay, we have this particular industry, we want you to come and tell us like, should we be producing more drugs or at a lower price, or should we actually reduce the supply of drugs and increase the price, right? And then when you go there, like what they want you to do is they want you to say, okay, here's the data, here's the relationship that I believe exists between supply and demand for the drug and the active price, and then here's the analysis that I'm going to do to provide an answer. Here are the assumptions that I've made, and knowing what these assumptions are going to help us to figure out how reliable the answer is that we get to this question. And so the goal of this course really is to get us to that point where we feel very comfortable having a very sophisticated set of tools that we can use to answer these types of questions. So that when you go to employer, you can say, hey, I know how to run a regression, I know what the core elements of it are, I can kind of like do it from scratch, I know how to implement this data, I know how to interpret coefficients, I can tell you what these coefficients mean, I can tell you what this means to the bottom line of the business. And that's exactly where we're going. And so in the homeworks, one of the reasons why I did like a very extensive primer at the beginning and why this course has been very demanding up until this point is because I want to set very high expectations of you, so that when you go into the labor market, you have that confidence to know that if you stand with a peer from Harvard or Princeton or Stanford or Duke or University of California, Berkeley, that you are just as good as he or she is, and you know how to do this stuff. And the hope is that the more that you've done this through the homeworks, the more confident you've become being able to implement this. And so maybe at the beginning you felt like, oh my God, like I've been so calculus since like freshman year of college. But like now you're like, okay, I can do this, I can do this. It may not yet be second nature for you, but the whole point is getting you to that place where it's second nature. And it's very related to the economics too. Because when we think about, take for example the derivatives of marginal utility. When we think about what happens when you're choosing the optimal bundle given a budget constraint, what you're really doing is you're equalizing the marginal utility per unit dollar across all of the different objects that you can spend. Right? So like at the optimal quantity, if I'm choosing between Snickers and movie tickets, then the incremental amount of utility that I get per unit dollar spent on Snickers is going to be equal to the incremental utility per unit dollar that I spent on movie tickets. And so like the mathematics isn't extraneous to the economics, but the mathematics really helps inform the economics. And so like if it ever feels like it's just we're doing mathematics, like let's ask the question, hey, like how does this connect to the economics? That's a totally legitimate question. But all of the mathematics that we develop in this course, my hope is that we can see what the connection is to the economics that we're studying. Other questions?
I was wondering if you would upload any previous midterms or have like more questions.
Yeah, so that's a good question. How about we do this? So I'll create a wiki, And you guys, looking at the homeworks, can generate questions that you can solve and put answers to. And we can generate the bank that way. Because legitimately, I mean, I'm not being facetious, but legitimately, like the way that everything that we do is going to be a derivative off of what we have seen on the homeworks or in the class. And so I am not a proponent of like just creating like a huge test bank and just having people like work through a lot of problems. But if that's something that we want, what we can do is we can create a wiki people and say, hey, this is a variation of a problem that I've seen. I'll think about it this way, or I'll think about it that way.
Would you be able to see it and check that they actually make sense?
Well, each of you have the tools, right? Because it's a wiki, like you can say, hey Tom, that's an awesome question, right? Like this is the answer. And Tom, like, yeah, like this is totally the answer, right? And then Ali can be like, this answer is so wrong. The answer should be this, right? And you can even do that among your classes. How many of you guys have used the wiki before? If not.
Yeah.
I did.
No, I mean I think it's a phenomenal suggestion. But like my whole approach as a professor is like I want you to be actively engaged in your own learning. Right? I'll tell you a story about this. So my freshman year of college, we had this physics class, and this physics class was crazy because we're freshmen in college, and we had to know multi-variable calculus. So this is like third semester calculus that you probably learn as think of it as a sophomore or something like that. We had to know differential equations, and we also had to know linear algebra. And this is like first day in college, like walking into this class. And so when the final came, the professor did this thing where he had about 300 questions that were posted online, and each of them were like 20-point questions. And he said, your final is going to come from this test bank. So if you solve all of these questions and you know the answers, you'll totally get it. And this is what happened. This is a true story. So one of my friends who was really bad, he went through all of the questions. Maybe it wasn't 300, maybe it was 120 questions. And he solved every single one of them. I, on the other hand, I took my notes and I read them from cover to cover the night before, and I was like, okay, boom, 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 boom. And that's how I study, because I'm a very conceptual learner. It's like, if I understand the concept, like any given problem is just an instance of that concept, and I can solve it, right? And so, like, he may have spent like about 6 or 7 times as much time studying for the exam as I did. We got the same grade. But we can. I think the way, Anna, to really take your question very seriously, I think the way to do it would be for us as a class to come up with these types of questions, and then we can fact check each other. And I think that would be really cool, and that could be something that we can use for future lessons. But everything that I've said so far is like the 4 types of questions that we will get, like those will be on the exam, can be variations of what you've seen on the homeworks and on the midterms, and so like it won't be. You shouldn't walk into the test and be like, oh my god, like I can't believe I'm seeing this question. Where did this come from? Is that helpful?
Yep.
Okay. But if people want to do them again, to believe easier. Other questions?
I wish I believed in us as much as you do.
Say that again. Say that again.
I wish I believed in us as much as you do.
Why don't you believe in you?
I don't know. I just took a rough test on Tuesday in economics, and it was just like, you'd seen it all, but like anything like can happen in economics, and it's just like you never know what you're gonna get.
I feel like we're gonna have one of those other ones, so that's not going to happen.
I literally put nothing past the Econ test. I can understand a finance test, but like economics, like you can. My teacher was literally like, if you can just describe to me that you like know it, I'll give you all the points. And I was like, it's gonna take me 2 hours to write down everything I know just to make sure that you understand this. And it almost did. But I don't know. I just feel like anything can happen on an economics test. That's like been my experience. It's just scary.
Okay, so let me write down. You guys all have down the questions that can possibly come. Right? Like the true or false stuff can kind of like come from whatever, but like the other main question categories are literally going to be like very similar to what you've seen in the homework. It'll be like a variation of it, but like it shouldn't be like a super duper.
There are going to be numbers in this, right?
Yes.
Okay.
There'll
Thank you.
There'll be numbers in it.
All right, that's big.
Yeah.
Because that was part of
That's
what made
good.
that
Yeah, that's-
derivative
That's a good
on.
point.
Yeah.
Because that's what part of made that derivative on the theoretical exercise such a bear.
Yeah.
Because you were doing the quadratic with like 5 other variables.
Yeah. You guys did great. I mean, like, you really, that was a non-trivial,
Question if we can get any of our homework for
oh,
feedback.
yes.
That I don't know if I'll get to before the weekend.
Okay, which homeworks are you guys making them?
A lot of
Okay,
them.
so we understand. Okay, so we'll talk after, we can talk after class and we'll try to get those back to you, Zach. At the very minimum.
I don't want to overload, but.
What we can do is, but I think the solutions we can get.
The solutions.
Yeah, the
would be
solutions
helpful.
I'll get up
We
there,
can
yeah.
get back,
Yeah,
we
I
can
think
get
that
back
would-
to
Yeah.
solutions.
that would be
That's
good.
fine.
That will definitely be up there before this weekend.
That was what I was gonna suggest.
Yeah, we can get back to solutions too. Other questions? It's good to see you all like a lot more relaxed because I think people are petrified. And I started to think, I was like, what kind of a professor am I? Like, people are really afraid of the stage. But don't be afraid, like, everything that you need, you have the tools to be able to accomplish through this class. Okay, other questions? Other questions about your intern? Okay, so we spent a good half an hour talking about your intern. Let's take a Adam.
Sorry, will we get method points, so like if we get the like, steps, you know, like,
Yeah.
somewhat correct?
That's a great question. So like, you notice the way that I solve problems on the board? It's like I always put every step. Like, don't go and think you're a total boss and you can just skip steps. Like, I do not recommend that because there are 2 reasons why. Like, one, you won't get the partial credit if you get something wrong. 2, if at the end of the problem, what you do is you realize that if at the end of the problem you realize that something is wrong and you go to correct it, it's like because you had such a scant amount of notes, you don't even know like where your solution went sideways. So please do that. You will certainly get points for method. The one thing that I didn't mention is we also did game theory and dash responses too. So that's also something that's fair game for that's also fair game for the term, right? And so we have profit maximization, utility maximization, the dash responses as well too. So that as well is fair game. But everything like you have seen and you've done. Yeah. You're gonna be so satisfied with yourself after coming to this test. You're like, wow, like we've learned so much in just such a short time. Okay. All right. Any other final questions before we break and then we come back and just talk and stuff? All right. So let's take a 5-minute break and then after that we'll reconvene.